Come to me. Am I audible? Is my voice on screen is clear to all of you? Guys, everybody please respond to me. All of you get my voice on screen. Those who are attending in online. Am I audible? Is my voice on screen is clear to all of you guys? Now please confirm to me. Please type in questions box. All of you get my voice on screen. Those who are attending in online. Am I audible? Fine. Right. Good morning, guys. Right, sir. I think all of you are having this link, right? So daily classroom notes is going on with this particular link only. If you're not having it, now try to take picture of it. https://tinyurl.com/core java830. So daily, the total document is shared through this link only. You can take it. Okay. All right, sir. Now, the next one after this, the topic is like what there. In the last class, just we completed Java history. The total, what is the background story of the Java programming language, the total, then we completed the total content. Just I want to discuss about the pinpoints about this total Java history. Let us understand that pinpoints clearly. Sun Microsystems wants to prepare a new programming language to prepare softwares for the electronic consumer devices like cable TV switch boxes, remote controllers, and so on. That's the main intention. For that, they gathered 30 members team led by James Gosling and Patrick Norton. They started a project named Green Project. Part of the Green Project, they want to prepare a new programming language with three features mainly. What are the three features here? Simple programming language, tight coded, architectural neutral. What is the meaning of simple programming language? Less execution time. It yields more performance. Less memory. It implies less cost for the end product. Less power. So it yields what there? Less maintenance cost for the end product. Then after that, tight coded. What is the meaning of tight coded? Less number of finish sections, more implementation. Less number of finish sections, more achievement. That's the meaning of tight coded. After that, architectural neutral. That new programming language should not bond with any particular hardware system. It must be available to every hardware system. It must be compatible with every hardware system. That's the meaning of what their architectural neutral. After that, they took nearly 2 years of time to complete the new programming language. In 1992, December month, they completed new programming language. Then they want to give a name to the new programming language. James Gosling has suggested Vogue is a name, but it was already existing name, existing programming language name. So Sun Microsystems has not accepted that. Later on, all the Sun engineers have suggested the name for that new programming language is Java. Why? Because they likes to take Java coffee or tea, whatever it may be, at their cafeteria. That is the reason why the name of the programming language is what their Java programming language. Right, strictly speaking, Java is one of the island in Indonesia. That place is famous for coffee powder or coffee trees agriculture, something else now. With that land name only, that coffee powder was released to the market. Because of that reason, Java is a coffee there that was used by Sun Microsystems cafeteria. Unfortunately, all the Sun engineers, they used to take the same copy. By having this thought, they want to give name for this new programming language is what their Java. Finally, we have the name for this new programming language is what their Java. Leave it. After that, in the at the end of the 1992, Sun Microsystems has prepared the very first product. on the base of the Java, that is star 7. The star 7 is a remote controller actually, but it was a failure product. It was totally what there, a failure product. Almost all, it was a failure product. Sun Microsystems has waited nearly 1.5 years of time to find the customer for star 7, but no customer is identified. In the mid of 1994, there is a boom for browsers, part of the internet. So demand is available for the browsers. Sun Microsystems wants to prepare their own browser they want to prepare. That responsibility was given to Jonathan Payne and Patrick Norton. They prepared the browser. At the end of the 1995, they're given a browser. The name of that browser is what their hard Java browser. That hard Java browser is a successful product from the Sun Microsystems. By the time everybody is thinking what is there internally inside the hard Java browser, everybody understood that there is a new programming language at Sun Microsystems, that is Java. On the base of that Java only, hard Java browser was prepared. So then immediately people are talking about Java programming language. As per the request from the outside market, Sun Microsystems wants to release Java programming language to the outside market. As part of that, they released that Java first version with the name JDK 1.0 in the 1996 January 27th. That may be January 27th or 23rd is a bit confusion, but January month, whatever it may be, 1996 January month. Then they released the first version. From that point onwards, every 1 year or 2 years of time, they released some versions of the Java. JDK 1.1, JDK 1.2. I listed out what are the major versions and what are the minor versions. At present, the latest version of the Java is what there? Java 22 version, 1.22 version. This is the total Java history, what we have seen in the last class totally now. Right. Then after that, now we are going to understand the topics like what there differences between Java and others. Differences between Java and others. This is a topic. So here we have to understand it. This is a title. Differences between Java and others. Right, sir. Then previously we are having Java history as a topic. Java history. Right, sir. Now the topic is what the differences between Java and others. Right. Not required. So under these differences between Java and others, we are going to see a number of differences. Nearly 9 differences here I am providing. All these 9 differences are important. You must understand that each and every difference clearly. If you understand these differences clearly, you are going to have some knowledge on Java. How Java is very good when compared with the C and C++. Understand it clearly. Not only that, in general, in outside, people are thinking about the Java. If you want to learn Java, first we have to learn C++. If you want to learn C++, first we have to learn C. Then they're forming a chain process. First, people will learn a C programming language. After that, C++. Then after that, people are coming for what? Java. But this is not right. This is not right. This is blunder. Understand it now. In Java, core Java is available. That core Java is a fundamental course. Those who are not aware about the computer science, to give some knowledge on Java, that core Java is available. It is a fundamental. Further fundamental, again another fundamental course is not required. In which way C programming language is available, in the same way core Java is available. How much efforts we are going to put to learn C programming language, the same effort we can put for what their core Java. Then we are able to get the total basics. Right. To show at least that particular point, I'm going to take the topic like what their differences between Java and others. Right. Now let's understand what exactly the points here we are going to understand there. The very first point here I'm telling to you, observe carefully. C and C++ are static programming languages, but Java is a dynamic programming language. But Java is what there? A dynamic programming language. This is exactly the point here we have to understand. This is the first one. All of you understand it clearly. What is the first point here I'm telling there? C and C++ are static programming languages, but Java is a dynamic programming language. Clear? Before going to understand that C, C++ are static programming languages and Java is a dynamic programming language. Before understanding this point, what I'm telling to you, observe carefully. All right. Now the point is what there? First of all, what is a static programming language and what is dynamic programming language? First, we are going to understand it. First, we have to understand what is static programming language, what is dynamic programming language. We'll understand it. After that, we'll come back to the C, C++ and Java, whether they are static programming languages or dynamic programming languages. Right, sir. Now, I'm going to ask some basic questions. Now, try to answer for it clearly. For example, well, if I understand it, no. For example, I have written a C program. I have written what there? A C program, for example. When I say it's a C program, automatically the file extension is what there? .c. It's a C file. .c is a file extension. Some file name .c. Okay, fine. Now inside this C program, I've written some instructions. A set of instructions here I've written. These are all the instructions that we have written. Next one is after that, after completion of this, for what purpose here we have written C program? If I execute this program, then I'm able to get some output. If I execute this program, then I'm able to get what there? Some output. So I have to execute the program. Now I'm ready to execute the program. This is execution process. This is like what I'm telling there, execution process. All right, now by the execution of this program, automatically here we are able to get some outputs. This is output. This is the output here we are getting. Okay. Now execution is performed by a machine. That means who is executing C program? That's the question. Which is executed by a machine. What is the name of that machine actually? The general terminology, C engine. What is it? C engine in general. Specific names may be available. I'm not thinking about it. C engine is able to execute our C programs. To execute C++ programs, we are going to use a separate engine, that is a C++ engine. To execute Python programs, we are going to use a separate engine, that is a Python engine. Python engine is also be called as PVM. PVM, Python Virtual Machine. Similarly, to execute Java programs, we are going to use a separate engine. That engine name is what there? Java engine. The Java engine is also be called as JVM. JVM, Java Virtual Machine. PVM, Python programs. JVM, Java programs execution. PVM, Python Virtual Machine. JVM, Java Virtual Machine. Got it? What is the point here I'm telling to you? Know? Okay, fine. So C engine is available. Now, all of you understand it clearly. Here the point is what there. If I send this program directly to C engine, it has to execute this program and it has to generate some output. That is the actual idea. But there is a problem here. What is the problem? No, all of you observe carefully. Now tell me, who has written the C program? Come on here. Who has written C program? Developer, programmer. We have written the C program. Developers have written C program. Good. How developers are able to write that C programs? How developers are able to write C programs in their understandable language. Developers are able to write C program in their understandable language. Am I right or not? Developers are able to write the program in their understandable language. What is the understandable language to the developers actually? The developers understandable language is what their high level language. Developers understandable language is what their high level language. What is this high level language? Any example for it? No, very simple. Int a is equal to 10. This is understandable by the developer. This is high level syntax, high level language. Int as developer can understand integer data. A is a variable, equal is an operator, 10 is a constant, semicolon is a terminator. The developer can understand. This is a high level representation. Okay, fine. Now this is an example for what their high level. Okay, developers have written program in high level language int a is equal to 10. This is an example. But when it comes to C engine is able to execute the C programs, no doubt. But which representations it is able to understand? That C engine is able to understand what type of representations? No, that C engine is unable to understand the developers who written a high level language. C engine is a mission basically. It is unable to understand the developer's understandable language. It requires the program, or it understands the program in a low level language. It is able to understand the programs in what their low level language. All right, sir. What is this low level language actually? If you understand that low level language, the same into a is equal 10 is going to be represented in the form of like what there some zeros and ones. This language is nothing but what their low level language. In other words, we call it as a mission language. Sir, got it or not? This is what their high level language, developers language. This is what their low level language, mission language. Now tell me, now developer, he is able to write the C program. He written that C program. He has given that C program to the C engine. Then what C engine is expecting actually? C engine is expecting the program in what language? No, low level language. But developer has provided program in what language? No, high level language. When we provide a high level language to the C engine, is there any chance for C engine to execute that high level language? Is there any chance for C engine to execute our understandable high level language? No, not possible. There our program is not going to be executed. There our program is not going to be executed. Then what is the solution for it? Now I'm telling some solution here. Observe carefully. Here two options are available. What are the two options? No, option number one. We need to prepare the C engine to understand high level language directly. Not possible. Leave it. Then remaining second option is what there? We need to search for some translators to translate the program from high level language to low level language. Either we have to redesign the C engine to understand high level language, that is provided by C programming language vendor. That is not in our hand. Being the developer, I'm unable to do anything with the C engine. Just I can give only some program to the C engine. It has to execute it. But manipulating that C engine is not in our hand. So not possible to redesign C engine to understand high level language. Leave it. But the second option, what is the second option I'm telling there? We have to search for some translators to translate the program from high level language to low level language. If any translator is available, then our requirement is going to be achieved. Right, exactly. Some translators are available in our side. There we are going to get what there some translations. Now understand it clearly. Now this is like what I'm telling to you, a translation mechanism. This is like what I'm telling to you, translation mechanism. Translation mechanism. I'm going to give this name here, translation. Later I'll remove this name, then I will give some other name here. What the translation is able to do? No, if I give this C program, high level program to this translation mechanism, this translation mechanism will convert the program from high level language to the equivalent to low level language, equivalent to mission code. It is able to convert that high level program to the equivalent to mission code. The total mission code, the total low level language is going to be provided in the form of a separate file. That separate file is what there .exe file. Inside this .exe file, how the data is going to be available here? No, the data is going to be available in the form of like what there, like in the form of some mission code. This is like what I'm telling to you, mission code. Now it is existed clearly. This is created. Whenever we are getting that low level code, I'm telling to you, this is exactly like what there, a low level code. This code is nothing but what there, low level code. Whenever it is a low level code, low level language representation, whenever it is a low level language representation, if we give that low level language representation to the C engine, now C engine can understand that program, C engine can execute that program, and the C engine is able to provide some output from this particular program. I'll forget my point or not. If I give this high level program to the translation mechanism, it will translate the program from high level representation to what there, high level representation to directly low level representation. That low level program will be provided to the C engine, where C engine will execute that low level code, and the C engine will provide some output. I'll forget my point or not. Now coming to this translation mechanism, the translation mechanism that we have used to translate the program from high level representation to low level representation, then the translation mechanism is called compilation. The translation mechanism is called what there, compilation. Straightly I'm asking one question to you, try to answer for it. What is the main responsibility of the compilation? What is the main job of the compilation? Now tell me here itself I'm giving clarity. What is the main intention of the compilation? Translating the program from high level representation to low level representation. Why this translation is required? Why this translation is required? C engine has to execute the C program. That C engine is able to understand the program in low level only. So, but developers are able to write the program in what level? High level. But C engine requires the program in what level? Low level. So we need a translation mechanism to translate the program from high level representation to low level representation. To translate the program from high level representation to low level representation, we have to use compilation process. We have to use what there? Compilation. What is the main responsibility of the compilation? Is to translate the program from high level representation to low level representation. All of you are comfortable? All of you are getting clarity up to now? Can I move forward? Next point I'm telling to you, all of you understand it clearly. Now tell me, who has written this C program? Developer, programmer or developer. Okay, good. Developer or programmer is a human being, definitely human being, right? The fundamental right for the human being is what they're committing mistakes, having mistakes in their program. That is a fundamental right. Am I right or not? Arey yaar, even though if he calls James Gosling to write Java program, when he compile his program, he may get 10 number of errors. That's a minimum thing. Everybody will get errors. Even I thought of this Java programming language maybe more than 500 batches as of now. Example I'm telling there. In some situation, if I write the program, but still I'm going to get errors. Everybody will get errors. But what type of mindset you need to have there? I'm giving one simple point. When we are getting errors in our system, don't go away from our system. Then don't take the decision, I'm not suitable for software industry by seeing one or two number of errors in our system. Feel happy when we have seen the errors. No, feel happy. We are going to learn more subject. By rectifying the errors, we are going to get more knowledge. Then feel happy for it. Whenever we are getting errors now, then sit on the system, try to rectify the errors, try to recompile the program again and again, then try to find the output. Understand my point here now? So getting errors is a minimum of the minimum. If you are getting error, then only you are the right developer. If you are not getting error, no, you are not the developer. Understand it clearly now? Okay, no problem. Getting errors, that means doing mistakes in our program is a fundamental right for the human being. Okay, getting mistakes, having mistakes in our program is not a crime. Having mistakes in our program is not a crime. Understand my point clearly? But what is crime? Without checking our program, whether our program contains errors or not, without checking our program, whether our program contains errors or not, trying to execute the program directly is a problem, is a crime. Without checking errors are available or not, if you're trying to execute the program, then that is a crime. That is a fundamental mistake from your side now. Get my point or not? So before going to execute our program, we need to check our program contains errors or not. Before going to execute our program, we need to check whether our program contains errors or not. To check whether our program contains errors or not, we need to go for what there again? Compilation process. Compilation process will take the second responsibility, that is what there? Error checking. Error checking is the second responsibility of the compilation process. Right now, tell me, all of you now tell me, compilation, in the sense 2 points we have to remember. What are the 2 points? What is the first point? No, translating program from high level to low level. Second one is what there? Error checking. Simple words. Error checking. Whenever we are having error checking, immediately we have to recollect what is the meaning of error checking. It will check line by line in our program whether each and every instruction is properly provided or not. If any line is not provided as per C programming language rules and regulations, no, immediately compiler has to display some error message. That is the meaning of like what there? Error checking. Now let me list out these 2 points here. No, compilation in the sense two things. What are the two things? No, first one is high level language to, then what next one here? Low level language translation, and the second one is what there? Error checking. Error checking. They are the two responsibilities of what there? Compilation, that we have to understand. Clear? All of you are getting clarity up to now? Right. Now let's move on to the next point here. This is our required point. Everybody put more concentration now. What is the point here I required? No, observe carefully. So for example, int a is equal to 10, I have written, sir, an intersection. Int a is equal to 10. What happened when we execute this statement? Or when we compile it, or when we execute, whatever it may be, what happened internally if you write this intersection? What is going to be happen? First, it will recognize int, and it will recognize the variable name a. It recognizes the data 10. Immediately, internally, for a variable, depending on the programming language, some bytes of memory will be allocated. If it is C programming language, 2 bytes of memory. If it is Java programming language, 4 bytes of memory for integers. So whatever it may be, some memory will be allocated for that variable a. After that, value of a, that is 10, will be stored inside the memory. Yes, sir, this is going to be happen. When we write int a is equal to 10 in our program there, internally, in a simple point I'm telling there, memory will be allocated for the variable. In that memory, data 10 will be stored. All of you get my point or not? Okay, fine. Listen, all of you listen carefully. Memory allocation for the int variable. What happened here? Memory allocation for the int variable. In place of int variable, I want to say primitive data type. Int is a primitive data type, one type of data type now, like byte, short, int, long, float, double, boolean, character. Eight data types are available. All these are what they're primitive data types. They are the primary data types in our programming languages. Got it? No? All right. When we provide this variable declaration, memory will be allocated for the primitive data types must be taken place. Memory allocation for the primitive data type must be performed. Now listen carefully. If the memory allocation is provided for the primitive data types at a compilation time, if the memory allocation is provided for the primitive data types at what time? No, compilation time. Then that memory allocation is called static memory allocation. That memory allocation is called as what there? Static memory allocation. Tell me guys, all of you know what is static memory allocation? If the memory allocation is provided for the primitive data at what time? At a compilation time, then that memory allocation is called what there? Static memory allocation. Nice. Similarly, all of you understand it clearly. If the memory allocation is provided for the primitive data types at a runtime, at the execution time or at runtime, then that memory allocation is called dynamic memory allocation. That memory allocation is called what there? Dynamic memory allocation. Guys, all of you now tell me, what is static memory allocation? What is static memory allocation? Memory allocation and compilation time. That is static memory allocation. What is dynamic memory allocation? Memory allocation at what time here? At runtime. Is what there? Dynamic memory allocation. All of you get my point or not? Static memory allocation and dynamic memory allocation. Clear? I'm coming to our actual conclusion. Put more concentration. If any programming language is following static memory allocation, then that programming language is static programming language. Tell me, what is a static programming language? If any programming language is following static memory allocation, then that programming language is what? Static programming language. Similarly, now tell me, what is dynamic programming language? No? If any programming language is following dynamic memory allocation, that is the memory allocation at runtime, dynamic memory allocation, then that programming language is what there? Dynamic programming language. Yes, sir. I'll forget my point or not? All right, sir. Now, our actual point is what there? Now tell me. My required discussion here I completed here. Actual difference is what there? Now tell me. What is our actual difference here now? C and C++ are what programming languages? Static programming languages. But Java is what there? Dynamic programming language. Now I'm giving the point. I'm going to give that actual point and try to understand it now. If any programming language, is following the static memory allocation, if any programming language is following the memory allocation, that means static memory allocation, then that programming language is called a static programming language. The programming language is called what there? A static programming language. Observe carefully. What is static memory allocation? I'm giving clarity. If the memory allocation is provided for the primitive data, not for user defined data, please remember it. For the primitive data, if the memory allocation is provided for the primitive data at compilation time, then that memory allocation is called what there? Is called static memory allocation. Static memory allocation. That's fine. Examples for it is what there? C and C++. What's the point I'm telling there? In the C and C++ applications, memory will be allocated for the data at the compilation only, at the compilation time only. Because of that reason, C and C++ are what there? Static programming languages. All of you are getting clarity? See, then every point you have to understand. These are somewhat technical points. Say, for example, if you go to your home, somebody else may ask a question to you, what you are doing now? You may reply to them, I'm learning Java at Durgasoft. I'm learning Java at Durgasoft. If you ask there, they may ask a question to you. Already we have C and C++. Why you are learning Java? Then indirectly they are going to ask, tell me the differences between Java and other programming languages. By the time, at least you have to open your mouth and you have to give at least a few points about the differences between Java and other programming languages. Why we are coming to the Java over C and C++, there at least we have to justify. And one more point I'm telling you, observe carefully. Now you are the fresher. Whenever we are in campus interviews or whenever we are the fresher there, we are going to prepare resume. In that resume, we are going to provide the option like skill set. There is a field. To the skill set, in general, what you are going to specify there? What technologies you are going to specify? As you are the fresher, as you are having more temptation, then people are going to specify whatever the technology names, you know that every technology name you are trying to keep in the resume. C, C++, Core Java, Advanced Java, Hibernate, Spring Boot, microservices. Not only that, Core Python, Advanced Python, Django, .NET, C Sharp, .NET, a total list of the technologies which are going on at Amirpet. Definitely, this is minimum thing. As you are the fresher, you want to think your resume should be strong. To maintain the strongness in our resume, we are going to give a list of technologies. But this is not at all suggestible. This is not at all suggestible. Then what I'm suggesting to you, while preparing your resume, you should not provide your unknown technologies. Which technologies really you know, that one only we have to specify. You know only C programming language, fine, specify only C programming language. Why? Because what is going to be happen at the end? Okay, you specified list of technologies. You went to that interview. The company had called for you for an interview. You went to that interview. In that interview, will ask directly. Interview will ask you give a resume. If you give a resume, if you give your resume with your hand now, it means that whatever the information I specified in that resume, that is right. I am perfect up to that details. That you are saying to that interviewer. Once the interviewer has taken your resume, if you see all the technologies list in that resume, then you are the responsible person to answer for any type of question from the list of technologies. Why? Because officially you are saying that that is my resume, they are my known technologies. Then definitely interviewer has the rights to ask questions on each and every technology. That's the actual thing. But what happened if you specify some Spring framework? If interviewer is asking questions on Spring framework, there you should not say I don't know Spring framework. It's a blunder. Why? Because in a resume you said I know Spring framework, but when interviewer is asking questions, no, I don't know Spring framework. If you say that, it's a blunder. There is no chance of selecting you into the respective company. Understand it, So that's why you're the fresher. That's why I'm giving that information there. Whatever the technologies you are aware, specify up to that only. Now we are learning core Java. Specific clearly core Java, I know. If interviewer is asking a question, how much you are aware about core Java, there we can specify that introduction is going on now. Now I'm learning that core Java. I specified it. Introduction is going on. Then within few months of time, I'm going to complete my core Java. Like this, genuine information you have to say. You should not say any like fake information to that interviewer. I'll forget my point or not. So that is the reason why. Okay, fine. In general, you may specify the technologies minimum C, C++, Java we are going to provide. At that moment, interviewer may ask this question as a first question directly. Tell me the differences between C, C++, Java. Then at least if you are getting this question, you have to open your mouth and at least we have to talk about the answers for this particular question. At least 2 to 3 differences we have to provide. There we can give one of the differences what there C and C++ are static, whereas Java is what there a dynamic programming language. Right, sir. Anyway, the point here I've given there in C and C++ applications, memory will be allocated for the data, for the primitive data, for the primitive data at the compilation time only, at the time of compilation only, or at the compilation time only. Because of that reason, C and C++ are what their static programming languages. All of you are getting clarity or not? Now coming to the Java, then what is the meaning of the Java here? Now observe carefully. The total content here I'm going to repeat for Java. Now try to observe carefully. Now here, first of all, I need to give definition for dynamic programming language. What is the meaning of dynamic programming language? Now modify the definition. If any programming language is following what? Dynamic memory allocation, not static memory allocation, then that programming language is called a dynamic programming language. Is that all of you get my point or not? What is dynamic programming language? If any programming language is following the memory, the dynamic memory allocation, then that programming language is called what there? Dynamic programming language. Alright, sir. If the memory allocation is provided for the primitive data types at runtime, at what time you know? Runtime, execution time. Runtime and execution time both are same. Runtime, then that memory allocation is called dynamic memory allocation. That memory allocation is what there? Dynamic memory allocation. Examples for dynamic memory allocations are what there? Java, then of course Python, and so on. So many programming languages. Except C and C++, nowadays every programming language is following what there? Dynamic memory allocation only. Completed. Now in Java applications, memory will be allocated for the data at runtime only. Memory will be allocated for the data at runtime only, not at compilation time. Because of that reason, Java is what there? Java is a dynamic programming language. That's clear. Now related diagram also we have given. Whatever the diagram I prepared, even the diagram also we have given there directly. Right, sir? All of you are getting clarity on this point, no? So this is exactly the meaning of like what there static programming languages and dynamic programming languages. Clear to all of you know? Right, sir. Can I move forward? Can I go for the second difference? All of you are getting clarity on this first difference, no? You should not forget it, no? You have to remember this for the long time. Up to at least up to 1 week of time, we have to remember it. Nothing is there. Static programming languages are following static memory allocation. That is the memory allocation is going on at compilation time. Example C and C++. Dynamic programming languages are following dynamic memory allocation. That is what their memory allocation is at what time, you know, at runtime. Their example is what their Java. Finish. Not more than that. Okay, leave this content here. Now the second difference here I'm telling to you, observe carefully. This is somewhat difficult to understand, but I'll try to simplify it. But your attention is also required every time. Now try to understand it. No, the second difference is like what there. I'll have to understand it clearly. Preprocessor is required in C and C++, but preprocessor is not required in Java. Preprocessor is required C and C++, but preprocessor is not required in Java. There is a difference here we have to understand. Okay, now observe carefully. Before going to understand whether preprocessor is required or not required in Java, in C, C++, first of all, what is preprocessor? What is the job of the preprocessor? And what is the location of the preprocessor in our programming languages? That we have to understand first. Once we are getting clarity on this preprocessor and its related content, then we are going to understand then whether this preprocessor is required or not required in C, C++ and Java. Later on, we are going to understand that points clearly. Yes, sir. I'll forget my point or not. Okay? Right, sir. And one my sincere advice to all of you, I think people are totally busy with running notes as now. Not required. I'm typing everything for you. I'm going to share this document for you. Just try to put complete attention here. Whatever the points I'm discussing, just try to put focus on it. No need to write running notes. There is a drawback with the running notes actually. Of course, it is suggestible in outside when people are not giving documents there, the clear cut document. They're okay, fine. We can write it now. But here the point is what I'm telling to you. Running notes are not mandatory here. Why? Because I'm giving everything to you, right? Every point I'm typing and I'm trying to provide you. But if you're taking running notes, what is going to be happen? When I deliver one point, you're trying to write it on notes. At the same time, we have to concentrate on my next point. I'm not going to give any gap for you to write the notes. The second point I'm going to talk. When I'm going to talk about the second point, half of the point only we are going to listen and half of the point only we are going to write the notes there. The problem is going to be happen, not complete information. I'm giving document, sit aramly, now try to understand the point, what I'm telling there. No tensions, with a free mode, try to understand the concepts now. Clear? Can I move forward? Now tell me, what is the second difference here now? What is the second difference here? Preprocessor is required in C and C++, but preprocessor is not required in Java. Right. First of all, what is preprocessor? What is the location of the preprocessor? That we are going to understand. Let's see the diagram here now. Observe carefully. I'm going to take a C program again. This is my C program. When I'm saying that it is a C program, that extension should be what there? .c. Right, sir. In the diagrams, I'm going to follow the same convention. If you want to prepare any C++ file, no, .cpp. If you want to prepare any Java file, no, .java. Like this, I'm going to follow the convention. Clear? I need to perform compilation or not? Definitely. Here we have to perform what there? Compilation. This is compilation. When we perform compilation, automatically here we are able to get some files. Now tell me, sir, what files here we are able to get after performing compilation? No? What files here we are able to get now? Tell me. There we are able to get what there? .exe files. Now try to understand it clearly. .exe files. Whenever we are getting .exe file, there we have to execute our program or not? Definitely here we have to go for what there? Execution process. To execute this program, what we have to do there? This is like what their execution process. When we execute this program, there automatically we are able to get some outputs. Now here we are going to list out like what their output values here we are going to list out. Right, sir. Now see this one outputs. Output values here we are going to provide. This is a diagram here. Now let me provide some details now. First of all, here we have to provide what their compilation. After this compilation, the next one is what their execution, compilation. Then what next one here? Execution. After that. Now this is about our total structure. Observe carefully. C program, compilation, .exe file, execution, output. Clear? Now, if we understand the compilation, maybe people are thinking about it. Compilation could be performed by only compiler. Compilation is performed by only compiler. No, this is not right. Compilation is a process of 4 missions work. Inside the compilation, 4 missions are involved. It is not like only one mission work. 4 missions work is available. At least I need to list out what are the various missions now. Right, so the very first one, the very first mission is what there? Preprocessor. The first one is what there? Preprocessor. The next one is what there? Compiler. Next one is what there? Compiler. Next one is what there? Assembler. Next one is what there? Assembler. The next one is what there? Loader link editor. Loader link editor. These are all 4 missions which are available in the compilation process. That's it. Now these are about like what there 4 missions which are available in the compilation. Preprocessor, compiler, next one is what there? Assembler, then after that loader link editor. That's it. It's okay, fine. One after another. Here we are, it's going to be performed actually. After completion of preprocessor, compiler. After completion of this compiler, assembler. After completion of this assembler, loader link editor. These are available now. Now, actually, my required point is what there? Preprocessor. Now, tell me, what is the location of the preprocessor? The location of the preprocessor is the first phase inside what? No, compilation. Preprocessor is the first phase inside what there? Compilation. Are you forgetting it or not? One more point. My required point is completed here. But compiler part also, because I'm going to elaborate. Why? Because in the future I require this compiler part also. What is that internal structure of the compiler that I want to know? Now let me complete it. Inside the compiler, if we take now nearly 7 phases are available. 6 or 7 phases are available. What are the 6 or 7 phases? Now, the first one is what there? Lexical analysis. Lexical analysis. Next one is what there? Syntax analysis. And the next one is what there? Semantic analysis. Semantic analysis. And the next one is what there? Intermediate code generation. Intermediate code generation. Next one is code optimization. Then after this, code generation. That's it. Overall, these are the various phases which are available inside the compilation. Compiler, especially inside the compiler, these many phases are available. Lexical analysis and syntax analysis, semantic analysis, and intermediate code generation, code optimization. Then after this, code generation. These are all the phases, all the structure internally which is available inside the compilation. Lexical analysis, syntax analysis, semantic analysis, intermediate code generation. After that, code optimization like this. This is spelling mistake. No, don't worry for it. Okay. Actually, then this is paintbrush is using the language support is what there from America actually. In American accent might be the optimization is going to be written like this. Understand it? But in general, regular what there, the spellings are different. But in one or two cases, the spellings are going to be different. Don't mind for it now. Okay. By default, it is generated actually. Okay. Just I have typed only one or two letters only there. Automatically, the remaining part is generated by this tool. That is the reason why we are getting it now. Don't mind for it. Okay. Right. Now let's move on to the point here. So this is the total compiler internal structure. All right, sir. It's okay. Fine. The total content is completed here. Now here my required point is what? What is my required point now? All of you observe carefully. Here my required point is what is the location of the preprocessor? That is my required point. What is the location of the preprocessor? Now tell me. This is the preprocessor location. Am I right or not? Preprocessor is like what there? Preprocessor location is what there? This is the preprocessor location. Okay, no problem. Now this is our required content here. We have to understand. All of you are getting clarity on this? Preprocessor. This is preprocessor. Understand this clearly now. Part of the compilation, the very first phase is preprocessor phase. That is the location here now. Okay, fine. After this, now we are going to understand what is the job of the preprocessor. The location of the preprocessor here we understood. The location of the preprocessor is what there? Now observe carefully. Preprocessor is the first phase in the compilation. Preprocessor is the first phase in the compilation. Nice. The diagram also we have given. But what is its purpose actually? What it is able to do? Now I'm going to give some clarity. Observe carefully. In C and C++, in C and C++, the complete predefined library, was provided in the form of header files. Am I right? Every programming language is having some predefined library. With the help of the predefined library only, we are going to prepare the programs. In the case of C and C++ also, some predefined library is available. That predefined library is provided by C and C++ in the form of header files. Get my point clearly? Header files. What are the examples for these header files actually? stdio.h. Have you heard about these statements? No? stdio.h. And the next one is what there? conio.h. And the next one is what there? math.h. And so on. So many things are available. Just only 3 of them are listed here. So many things are available. Okay, fine. In C and C++, the complete predefined library was provided in the form of header files. Examples are stdio.h, conio.h, math.h, and so on. Understand the points now. After that, all of you observe carefully after completion of this. In C and C++ programs, if you want to use predefined libraries, then we have to include the header files. Then we have to include what files? No, header files. In C and C++ programs, if you want to use predefined libraries, then we have to include header files. For this, we have to use hash include statements. For this, we have to use what statements there? Hash include statements. All right, sir. What are these hash include statements here? Now let us understand it clearly. Examples here I'm telling to you. Observe carefully. Hash include stdio.h, hash include conio.h, hash include math.h. Like this. Here we are having what there? Some hash include statements. Now tell me, all of you now tell me. First of all, I've given what is preprocessor. What is the location of the preprocessor? Preprocessor is the first phase in the compilation. Then what is its responsibility? What is its job? To describe the job of the preprocessor, now I'm talking all these points. In C and C++, the complete predefined library was provided in the form of what files? No, header files. What are the examples for header files? Now tell me. stdio.h, conio.h, math.h. Right, sir. No, okay, fine. How we are going to use these header files in our C and C++ programs? No, In a C and C++ programs, if you want to use predefined libraries, then we have to include the header files into the C and C++ files. To include header files to the C and C++ files, there we have to use a separate statement. What is the statement there? Hash include statement. Examples of utilizing the hash include statements. What is that example we are getting there? Hash include stdio.h, hash include conio.h, and hash include math.h that we provided. Now, all of you understand it? 2 minutes of time. For example, I prepared a C program. Everybody, put more concentration. I prepared what there? C program I prepared. I'm compiling the C program. I compiled the C program. When I compile the C program, the first phase of the compilation is what their preprocessor. What preprocessor will do now? Preprocessor will recognize all the hash include statements. Preprocessor will take all the header files names what we specified along with the hash include statements. Preprocessor will go inside the C and C++ softwares. Preprocessor will check whether these header files exist or not. Inside the C and C++ softwares, preprocessor will check whether these header files exist or not. If these header files exist, no problem here. If these header files are not existed, their compiler will raise an error. That means preprocessor will raise an error. These header files are not available in our C and C++ softwares. Like this, it is able to give some error. For example, if these header files are available in C and C++ softwares, immediately preprocessor will take all these header files. Preprocessor will take the executable code from these header files. Preprocessor will load these header files content to the memory. Preprocessor will load these header files content to the memory. This entire thing is going on part of the compilation or not? Come on. This entire thing is going on part of the compilation or not? No response now. Compilation only. That means predefined libraries are loading to the memory at what time? Compilation time or at runtime? Compilation time only. Predefined libraries are loaded to the memory at a compilation time. Loading predefined library to the memory at a compilation time is called static loading. Static memory allocation is different, static loading is different. Loading libraries to the memory at compilation time is called what there? Static loading. That process is called what there? Static loading. Is it? I'll forget my point or not? This is the meaning of static loading. Now tell me indirectly what I'm telling there. Preprocessor is performing static loading or not? Preprocessor is performing what type of loading? No, static loading. C and C++ are having what type of loading? No, static loading. Libraries are loaded at a compilation time only, not at a runtime. This is exactly the job of the preprocessor. Come again. What is the job of the preprocessor? No, when we compile a C program, what preprocessor will do? Preprocessor will recognize all the hash include statements. Preprocessor will take all the header files name from the hash include statements. Preprocessor will go inside the C and C++ softwares where preprocessor will check whether these header files exist or not. If these header files are not existed, preprocessor will raise some error. If these header files are existed inside the C and C++ softwares, then preprocessor will load these header files content to the memory. Loading libraries at compilation time is called what there? Static loading. Preprocessor is performing what type of loading? Static loading. C and C++ are following what type of loading? Static loading. That's it. That is completed clearly. That is the job of the preprocessor in a single statement to recognize and load header files content to the memory in a C and C++ programs. We need what there? Preprocessor. To recognize and execute hash include statements, in order to load the header files content to the memory, we require what there? Preprocessor. That's the job of the preprocessor. Just wait a minute of time. I'll list out the total content here. Whatever the information here I'm trying to specify to you. Now try to observe carefully. In C and C++, in a C and C++, when we compile C and C++ files, programs, when we compile C and C++ programs, the preprocessor will perform the following actions. What actions that preprocessor is able to perform there? Now point number one, preprocessor will recognize all the hash include statements. Preprocessor will take the header files names from the hash include statements. Preprocessor will take the header files names from the hash include statements. Preprocessor will check whether the provided header files exist or not in C and C++ software. Alright, sir. Preprocessor will check whether the provided header files exist or not in C and C++ softwares. If the provided header files do not exist, if the provided header files do not exist in the C and C++ softwares, then the preprocessor will rise an error. Error here we are able to get, will rise errors. Okay, fine. Error here we are able to get. If the provided header files exist in a C and C++ softwares, then the preprocessor will load the provided header files content to the memory. Right, so this is going to be happen. Now the point is what there, loading predefined libraries to the memory at a compilation time. Loading predefined libraries to the memory at a compilation time is called static loading. Is called what there, static loading. Now coming to the conclusion, what is the requirement of the preprocessor? What is the purpose of the preprocessor? The conclusion here I'm telling there. In C and C++, in C and C++, in C and C++, in C and C++, the main purpose of the preprocessor, or maybe I want to give a different conclusion. In C and C++, preprocessor is required. Preprocessor is required in order to recognize hash include statements, in order to load header files content to the memory. Right, sir. Header files content to the memory. This is the purpose of like what there, the total preprocessor. And C and C++ preprocessor is required in order to recognize hash include statements, in order to load header files content to the memory. All of you are getting clarity in these points now? Final conclusions. Finally, I'm asking there. Now tell me, all of you now tell me, what is the location of the preprocessor? What is the location of the preprocessor? First phase in what there? Compilation. Okay, fine. Next one is, what is the job of the preprocessor? What is the job of the preprocessor? To recognize hash include statements in order to load header files content to the memory. Because of that reason only here we are having what there? Preprocessor. Now tell me, finally now tell me, in C and C++, preprocessor is required or not required? In C and C++ applications, preprocessor is required or not required? Yes, it is required. Okay, fine. The related diagram also here we provided. The related diagram also here we provided. There preprocessor is available. At Java also we might be. The total content here I provided here. But this compiler internal structure I given intentionally. For the sake of the future purpose only, I given that compiler internal structure. As of now, that compiler internal structure is not required. For future reference purpose, no, I'm given that compiler internal structure. Okay, fine. This is completed up to C and C++. Now the turn is coming for Java. Why preprocessor is not required in Java? Why preprocessor is not required in Java? That point here we have to understand. First of all, I want to prepare the diagram with respect to the Java. Total Java here we have taken. With respect to the Java, I want to prepare the diagram. Now try to put more concentration here. Here, I want to go for some changes in this diagram. Observe carefully. If you want to make this entire diagram to Java, what changes are required now? Tell me. Come on, what changes are required now? First, I have to remove what? Dot C. We have to remove. In place of it, what we have to provide? Dot Java. In place of it, we have to provide what there? Dot Java. Observe carefully. All right, sir. After compilation of the C program, we are getting .exe file. But in Java, we are not going to have a .exe file. In Java, it's very clear that we are able to have dot class files. In Java, we are able to have what files? Can know dot class files. Remember one point. In C and C++, it's a bit confusion. After compilation, what files we are able to get? Maybe somebody else may specify .obj file, .exe file, .asl file. Like different files are coming. 3 to 4 different types of files we are getting. It's a bit confusion. But in the case of Java, no confusion. Before compilation, .java. After compilation, .class. Clear cut information. After compilation, .class. Before compilation, .java. No confusion in the case of Java. Right, sir. Dot class here we are getting. Execution process is okay. Now tell me, in Java, what is not available? What is not required? What is not available in Java? Entire compilation internal structure is same, but one is not required. What is that one is not required? No, preprocessor is not required. Preprocessor is not required. That's it. The remaining diagram is as it is. No need to think about it. Now I want to take this diagram here. I want to keep the diagram in the same document here. Now observe carefully. Right, sir. 1 minute. Right, sir. I'll provide this diagram, but about the Java here, I have to talk the information. All right. So do one thing. Then tomorrow we'll discuss about this content here, no, Java related. Why? Because time may not be sufficient. Even if we start it, no, minimum I required half an hour more time here, no. Okay. The time may not be sufficient for it, no. Then tomorrow I will discuss about the Java and its related content. But my request to all of you is what there every day before come for the class, try to check the previous class notes. Document I'm giving there. Try to thorough with the previous class notes. With that knowledge, if you come to the class, then you will understand everything easily. If you're not understanding this content tomorrow, what is going to be happen? Again, I have to start right from beginning to understand Java. There are given half of the point. Remaining half of the point I'm going to talk in tomorrow. But if you're not aware about this total content here, it's a confusion for you. That's why because of that reason, at least 10 minutes before you are coming here, in your mobile phone, we can open the document. At least the 10 minutes of time we can check the content. That's sufficient. Not required to take too much time here. 10 minutes of time is sufficient now. Okay, right, sir. That's all for today. I'll meet on tomorrow. Tomorrow is the remaining content. Thank you. Thanks a lot, guys, and those who are attending in online. There's a small intimation to you. I think within 1 or 2 days of time, the link is going to be expired. Link is going to be changed. Please register immediately. Those who are not yet registered. Those who are already registered, you will get a mail from Durgasoft with the new link data, with the new link information. But within few days, 1 or 2 days of time, the link is going to be changed. Okay. Yeah. Thank you, guys. Thanks a lot.